Hello and welcome back to the third episode of my God of War tutorial series. Today we will add quest markers to our radar, using most of the functionality created in the last episode. So let's dive right into it. In God of War you've got markers leading the player to various goals of main and side quests. That marker has a different color based on whether it's leading the player to a side quest, which would be blue, or to a main quest, which would be orange. Apart from that, we see the distance to the goal displayed a little above the actual marker. So let's create that. First off, let's start off with an enumeration that counts all of the different marker types. So in our case, only the two main and side quests. Let's create a new folder for enums. And in there, we'll right click and create a new blueprint enumeration. Let's call that e_marker types. If we then open it up, we can add our two elements. So first off, main quest, and second one, side quest. And then we can hit save. Let's also add a structure that contains all of the information we need for a quest marker. So in our structures folder, a new blueprint structure called s_marker info. Here we also only need two variables. First off is the type of that marker. And the variable type here will be the e_marker type we just created. And second one will be the position where our player should be led to. So that is a vector that we can just call location. Then let's hit save and close our structure. We want to display the markers on the radars, so we need another sub widget for that, just like we did with the directions. So let's go to our widgets folder and create a new widget blueprint called w_marker. Then let's open that up. Again, this is a widget that we will put inside of our radar widget. So let's make it desired on screen and remove the canvas. Like most times, we'll start with a size box and check the width and height override. The widget will have a total size of 30 pixel in width and 48 in height. In here, we want to have two elements. First off, the text for displaying the distance, and then the actual marker icon beneath that. So to align these two elements from top to bottom, we need a vertical box. Let's drag that in here. And let's start with the text. Let's make it a variable and call it the distance text. By default, it will read something like 999 meters. So just an amp for that. We want to reduce the size of that text by a lot. So let's make it light and a size of 8 maybe. And let's align that to the center horizontally. Let's also give that a shadow. So we'll bump up the alpha to 0.8 of the shadow. And if you zoom in, you'll see because we're using such a low size for our font, the shadow looks a little bit off. It's too far away from the actual text. So if you want to fix that, go to your shadow offset and we'll just reduce that to 0.5 in X and 0.5 in Y. All right. Then we want to add our marker icon, but let's wrap that by a size box and check width height override. Width will be 30 pixel and height 35. So that will fill out the rest of the area here. Want that to align center in both dimensions. And then simply add one image to your size box. That should also be a variable. Let's call that the marker icon. And if we just expand the brush and go to image, we've got the icon main quest and icon side quest. Let's select the main quest icon by default here. Compile, save, and that's it for designing your marker. Set over to the graph. In here we need some variables. So first off, we want to know about the type so that we can adjust the marker icon if needed. And the variable type will be an e_marker types. Make it instance editable and expose on spawn, so that we will define that when we later spawn marker widgets from our radar component. And the next variable that we need will be called max for maximum displayed distance. Let's make that an integer. If we just have a look at our text here, it is somewhat limited to 4 letters. If we would add another 9, that would go out of the boundaries. So we will say that the maximum displayed distance will be 999 meters. And if our distance is higher than that, we'll just write 999 plus to indicate that the distance is higher than that, but this here is the maximum we will display. So that's what this maximum displayed distance is for. We don't need to access that from other classes, so we can make it private, and let's give that the default value of 999. Then when we spawn our marker, we want to update the marker icon. So let's implement event construct, or rather event pre-construct, and grab your marker icon, then set brush from texture. You can hit match size. The marker icons all have the same size. And for the texture, let's use a select node and hook up the type as the index. For main quest, we'll use icon underscore main quest, and for side quest, icon underscore side quest. If you were to head over to the designer and select your W underscore marker, you would see the type appearing, and if we change that to side quest, your icon would update. There's only one thing left in here that we need, and that is updating the distance. So let's add a function called update distance, and we want to give it an input of type integer, which will be the new distance. Then let's grab our distance text and set text. And like I said, we basically have two different versions of the text. So either it's the amount and an M for meters if it's in the range of 0 to our maximum displayed distance. The other option would be 999 plus if that distance is higher than the maximum displayed distance. And to replicate that behavior, what you'll do is off of your distance, let's look for greater and hook up the maximum displayed distance. Then off of the boolean, we will use a select node and plug in the return value for the in text. If it is true, means we have to display 999 plus. We could just type that in here. However, that isn't very elegant because that maximum displayed distance here is a variable that we could change. So instead what we'll do is use a format node and then in curly brackets enter max. And after the closing curly bracket, we'll just add a plus. Then for the max, get your maximum displayed distance and convert that to text. Expand it, uncheck use grouping, and hook up the return value to maximum. For false, we also want to use a format, so we can copy that and plug in the result. However, this time it will not be max plus, but the amount in curly brackets and then an M. Grab the amount, we will get the distance and clamp that from 0 to our maximum displayed distance, just to make sure that we don't get any negative values here. And then we can copy our toText node, hook it up, and connect the return value to the amount. After we did all of that, simply add a return node to your function, compile, save, and that's it for the marker widget. We still have to add the functionality to add it onto our radar widget. So let's close our sub widget and go to the W underscore radar. Like with our directions, let me quickly show you what we want to do. So under user created, let's grab a marker and drag that onto our overlay. Right now that looks off. So if we spawn it, we want to set it to align center in both dimensions. And due to the fact that we added the distance text in here, the icon here will not be properly positioned on the radar. So under padding, we want to give it a padding of 4 pixels to the bottom, so that lines up. However, we have to do this dynamically, so let's remove the marker here. Just want to show you what we have to consider later when spawning that widget. Then let's go to the graph, and here we've got an array for all of our direction widgets. Let's do the same thing for markers. Call that marker widgets, and the type here will be a W underscore marker object reference, and then let's make it an array. Let's right click our add direction function and duplicate that for add marker. The input here needs to change. So what we need instead of the info is a type, and let's make that an E underscore marker types, and the output will still be called widget, but this time it will be an W underscore marker object reference. That broke some of your connections here. For our create widget node, we want to select different class, so that will be marker, and then you can hook up your type input to the type of that create node. After that, we want to grab our marker widgets and add to that. Remove the add node here and the direction widgets. Then let's hook that up to the execution and connect the return value as the item to add. After that, we will still add the child to overlay, and also set horizontal and vertical alignment to center. So for vertical, change that to center. And finally, off of the return value of your add child to overlay node, set padding. And like I mentioned, we want to give it a padding of 4 to the bottom. So let's split the in padding and simply enter 4 for bottom. Then we'll go to the return node and drag off of your create node here, the return value will feed into the returned widget. Save. That's it already for all of the widgets. We will proceed expanding the functionality of our radar component now so that it's able to display markers. Let's head over to components, BPC radar component, and let's close that function. First off, let's add one variable here called quest markers. So that will be an array to store all of the current markers. Type for that S underscore marker info, and like I said, make it an array. This one here will be a private variable, don't need to access it. And let's put that in a category that we'll call markers. We also want to be able to define default markers that appear when starting the game. So let's add a variable for that of the same type and call it default markers, or rather default quest markers. We'll put that in the configurations category and make it editable and exposed on spawn. We need a couple of functions that deal with adding the markers. So let's add a function, add marker to radar. This needs one input of the s_marker info type, call that marker or info, and let's promote that to a local variable, local info. If we want to add a marker to the radar, we also have to tell our quest markers array about that. So drag it in and add an element, which will be the local info. Adding it to the array, however, doesn't imply any visual changes, so we would still have to create the widget for it after that. So let's grab our radar widget and let's first off check whether that is valid. If it isn't, we can't do anything, so simply return. But if it is, off of it, add marker. And the type for that will come from a local info that will simply break first and then hook up the type. And we can copy our return node. And save. We've got the functionality to add a marker to our radar. However, we have to update the positions of all of our radars on the radar and the distance tags. So let's start with distance. Let's add a function called update marker distances. And we want to execute that function for all of the markers. So let's grab our radar widget reference, get the marker widgets array, and off of this run a for each loop. We already know that off of our array element, we want to update the distance. However, we still have to figure out what that value is. And after that loop is completed, we can return. Let's figure out what the distance is. First off, drag in your quest markers and get from them, get a copy at the array index. If you break that, and let's hide the type, we get the location of that quest marker. That location contains X, Y, and Z. Let's just simply break that to show you. Usually, when the distance between goals is calculated in video games, you take out the Z value. And to do that, we will call makeVector and only hook up X and Y from our break node. So that is the location of our quest marker. To get the distance, we have to subtract from that. So vector minus vector, copy the break vector and make vector node. Because for the player location, we will also take out the Z, hook that up to the subtraction, and get your player and camera, player reference, get actor location. Hook that up to the in vector. All right, so after subtracting that two vectors, we will get the vector length. So we will take out the direction of that vector because we don't care about that. And we have to divide that by a float. Currently, that vector length is in Unreal units, and these are very high numbers. We will convert them to something like meters or steps, whatever you want. So what is currently a 1 here, let's promote that to a variable called units per meter. Make that editable, exposed on spawn, and put that in our configurations category. Then we'll compile and save. And I just experimented with some values to figure out what is working. So a value of 150 worked fine for me. After we've divided that, let's also round it so we get an integer that we can then plug into our distance. And save, close that to functions. Last function we'll need is updating the positions of that markers on the radar. So hit function, update marker positions. And same as with the distances, we have to run a for each loop on the marker widgets of the radar. So I'll just copy it from here and paste it. Once that's completed, we can simply return. And we have to do some of the calculations that we already did for our directions. So you should be quite familiar with that. Let's get rotations to translations. And now we have to figure out rotation A and B. Rotation A is pretty simple. Simply drag in your camera reference and get world rotation. Then hook that up to A. For B, we basically have to find out which direction we would have to face in order to directly stare at the quest goal. Every time you need something like that, you have to call find look at rotation. So here you can plug in a start point and an end point. It will give you the rotation between those two. Start point, again, is very simple. That would just be the location where a player stands. So get actor location for the start. And for the target, let's drag in our quest markers and get from them at the array index, then break it and hook up the location as the target. Then off of InRaider's side, let's add a branch or an if statement and hook that up to the loop body. So if the translation is so high that it's not InRaider's side anymore, we would simply grab our array element and check whether it's currently visible. Is visible, then add another branch, hook that up to the false path of the first branch, then connect is visible as the condition, and if it is visible means we would want to hide it. So off of the array element, set visibility to hidden, connect that to the true. Then off of the true path of our first branch, off of your array element, set render translation, and that translation comes from our rotations to translation node that we created in the last episode. And after that, let's copy that branch here and again check for is visible, because if it's not visible, we want to set the visibility to self-hit test, so show it. Then off of your target, let's hook that up to the array element. All right, compile and save that. Close your two functions. Back in our event graph, remember that when we initialize our radar, we also updated the direction widgets. We have to do the same thing for our markers. So let's add some space here. But first off, we have to grab the default quest markers and put all of the elements from there into our private quest markers array. So grab your default quest markers and run it for each loop. Hook that up to the completed of the last loop. And then we will simply call add marker to radar and hook up the array element as info. Then after we did that, we want to update the marker distances and positions. And after that, we can update the direction widgets. Hook all of that up to completed and compile and save. When we turn around, we are currently already updating the direction widgets, but we also have to update the marker positions because they're also based on where the player is looking at. And the other thing is that we want to update the distance when the player moves, so the player can see whether he's approaching the goal or walking in a completely different direction. Let's add a custom event called onPlayerMoved. We also only want to do something if that radar is currently visible, so paste that. And if it is visible, we want to update the marker distances and also update the marker positions. The marker positions are based on the lookat rotation between the player location and marker position. That would also change when the player moves. Alright, we got all of the functionality of our radar component. That onPlayerMoved event isn't called right now, so let's do that. The only place where we could do that is in our third person character. And in here you've got the movement input. Input axis move forward and move right. Let's add some space. Like with turning around, these axis events are always called, sometimes just with an axis value of 0 if you're standing still. So let's check that this axis value is not equal to 0 and add a branch. And if so, we can grab our player radar and call onPlayerMoved. Then let's copy that node and the branch and paste it for move right and hook up the axis value. Compile and save. We've got all of the functionality in place for adding quest markers to our radar. If you select your player radar under configurations, you now got a default quest markers array that you can simply add elements to and then define main quest or side quest and the location. One simple way to place these kind of goals in your world would be to simply search for a target point and move that somewhere. For example, let's add one in the right corner here. Then we can copy the location, select our third person character, and in the components tab, go to player radar, add a default quest marker, expand that and paste the location. So let's say here that would be the main quest. And then I'll just add another target point somewhere on that kind of stairs here. Copy that location, go back to your player, to the radar, add an element, let's make this one a side quest and paste the location here. One issue that I found in our project is that on the input axis turn, we're only calling the update direction widgets function of the radar. Remove that, that's wrong. We want to call onPlayerTurned. Then compile and save. If we then play test, everything should be working fine. I'm in play mode now. You see two markers on our radar. First one, which is blue for a side quest, 9 meters away. And the second one that is orange and 12 meters away. So if I simply turn around, you can see them moving on our radar. And if we're facing a different direction, they would be hidden until we're inside again. Also, if we move, their position on the radar also updates. And as you can see, the distance decreases when we're approaching that point, and again increases when moving away. Alright, that's it for adding quest markers, and that is the end of this episode. In the next one we will add landmarks to our radar, so see you then.